Hello, my name is Mariela Sandoval. I'm a senior at Beloit Memorial High School, as well as an intern at the Welty Environmental Center in Beloit, Wisconsin. My globe research studied the effects of temperature readings on sugar maple sap flow. It has been found that warmer temperatures have a positive effect on sap flow, and overnight temperatures being more closely linked to producing more sap. This leads to my research question: how does soil, air, and surface temperature affect sap flow? To answer this question, we collected sap from 6 different trees around Big Hill Park, and we measured dBH with yarn and a meter stick. We used globe atmosphere protocols to gather air temperature, and as well as globe pedosphere protocols to gather soil temperature. We gathered tree temperature using an infrared surface thermometer, and for methods of measuring sap, we started off using a weighing scale and then later used a gallon bottle to gather the volume. What we found was that on colder days, it showed less sap volume, and then warmer days, it showed to have more variety in sap volume. And then in table 1, it shows the relationship between dBH and sap production on the 6 different trees that we tapped. In figures 2 and 3, it shows the relationship between soil and tree temperature to sap production. And as you can see, as the temperatures are increasing on both charts, so does the sap. Then if we take a look at the R-squared, you can see the soil temperature has one of 0.16 and tree temperature has one of 0.014. This means that although small, soil temperature does have a stronger relationship to sap flow. And so based on that information, we can conclude that soil temperature shows to have a greater contribution to sap flow than tree temperature. This makes sense because sap comes from the roots, so if the soil is too cold, it won't be able to bring in the moisture and dissolve the starches needed to produce sap. Therefore, drastic changes in day to night temperatures are found to be more reliable for the sugar maples who needed to know when it would be the ideal days to collect sap. Then, if we take a look at table 1, we can see that sap flow isn't affected by dBH, which I found was surprising because I expected older trees to produce more sap than the younger trees. But that was not the case because one of the younger trees ended up being the ones that produced the most sap. During our research, we had many limitations, and time was a big limitation for us due to the maple season only lasting a few weeks. There were also many snow days which prevented us from collecting data, and we would have to replace old bags and start from scratch to ensure that it was gathered in a 24-hour period. Also, using a regular weighing scale wasn't as effective because there was a weight limit of 2,000 grams, and also weighing a liquid bag on a flat surface was not ideal. Possible future research could be done by collecting overnight temperature data along with regular daily data collection and seeing how heavily sap flow is affected by overnight temperatures. During my internship, I was able to get more experienced and familiar with new ways of research and data collection. Also, being out in the field was very exciting for me, and seeing my data and research come to life was so amazing. It helped me come to a greater understanding of my research, and I kept on learning more. I would like to thank the National Science Foundation for funding Michael Notaro at the UW-Madison Center for Climatic Research, and everyone at the Welty Environmental Center for field assistance and logistical support.